Hey everybody. So this is Mr. Rogowitz. What we're going to do today is we are going to do one of our most important building block skills for algebra. And what we are going to work on is we are going to, I know the drama is awesome. Our goal for today is we will solve and prove one-step addition and subtraction equations. Give me just a second to get that down. Okay, so the difference in what we've been doing is we've been working with expressions. And remember that an equation has an equal sign. So it has an equal sign. It also has one solution to it. What we're going to do is we're going to do a specific series of steps that we're going to show you exactly what the work needs to look like every time. It is that important. Some of the math you may look at and go, oh, I did that in my head. And that's great. We would expect that because you're strong mathematicians. But you have to show all the steps. This is a building block to us solving more complex problems. So one of the reasons that middle school students are perfect at solving equations is because we use what are called the two I's. The two I's are first, inverse operation. And what an inverse operation is, it is the exact opposite of what the problem is doing. That's why middle school students are so perfect at this. Because, think about it, at your house, if your sister or brother comes in and says, don't eat my brownie, what's the first thing you want to do? Eat the brownie. So whatever they tell you to do, you're going to solve it the opposite way. So the first way we're going to solve is an inverse operation. Our second step is we want to isolate the variable. So we want the variable to be all by itself. Don't worry, it won't be very lonely for long. So we're going to start with a really simple addition problem. So let's go ahead and start with x plus 3 equals 7. Yeah, I told you, the math is not the complicated part. To solve this, we want to think in terms of this. The problem is adding 3. Our inverse operation is to do what? And if you said my inverse operation is to subtract, you are already good at this game. So what we're going to do is we're going to separate this side from this side. My inverse operation, if I was going to add 3 in the problem, what I'm going to do, first I'm going to change colors. I'm going to subtract 3 off of each side. Because when you're trying to solve equations, you must achieve balance. Whatever you do on one side of the equation, you have to do on the other side. So think about our inverses. If I have 3 and I subtract 3, what's left? 0. So the x is all by itself, or isolated. 7 minus 3 is 4. So what I've done, I used my inverse operation. I isolated the variable. The last step that you're going to have to do every time is you're going to have to prove it. So to prove it, we're going to use substitution. A proof, sometimes you'll hear it called a check, is I'm going to take the original equation, start with that, always start with that. And then my value for x is 4, so I'm going to substitute in. And then my last one, 4 and 3, 7 equals 7. You're looking at the math and you're thinking it's very simple. I totally get it. And it's critically important that you solve equations this way. Let's go ahead and try another one. So if I start out, I have negative 3. This is what's different than hopefully you did in 5th grade, is now we're going to start incorporating some integers or rational numbers, equals z minus 8. All right, so first step, I'm going to separate the two. Now I want to think, all right, negative 3 equals z minus 8. The problem is subtracting 8. What's my inverse operation? So what I'm going to do is now instead of subtracting 8, the exact opposite is I'm going to add 8 to each side. These are now going to become 0. So if I was at negative 8 and I add 8, I'm at 0. Variable's now isolated. Z equals, and then negative 3 plus 8, positive 5. Remember, we have to be fair on both sides. You must balance the equation. Now, next step, I have to have proof. Always prove equations. Original equation. Now I'm going to substitute in the value that we came up with. So negative 3 equals 5 minus 8. Negative 3 equals negative 3. If for some odd reason these two are not equal, when you put the proof in, you want to check that solution because it's possible you did something wrong. Okay, what we want to do now is we want to start incorporating some rational numbers also as well as integers. So I'm going to do C minus 7 and 6/10, 7.6, equals negative 4. So the first thing that I want to do is I want to separate. Now I know that I'm ready to do my solving. What's the inverse operation of subtracting 7.6? So now we're ready to do the inverse, which is we're going to add 7 and 6/10 to each side. So since I have two different, we're talking about a negative and a positive, these two will still cancel each other out. They'll become 0. C is all by itself or isolated, equals, and then negative 4 plus 7.6. We know it's a positive answer because our absolute value of the higher number is a positive. You subtract and find the difference. So our solution is 3.6. Now we think we're right. Come over, incorporate proof. So we take the original, C minus 7.6 equals negative 4. Sorry, sign that over for you. Incorporate and substitute, so 3.6 minus 7.6 equals negative 4. Negative 4 equals negative 4. So we've used isolating the variable. We did the inverse operation to solve it. And even though you did this, hopefully as a 5th grader, when you did 6th grade math, because solving one-step equations is something that usually you come to us with, we want to also talk about what's going to happen with a little higher level skills. So let's talk rational numbers. 2 1/4 equals R minus 4/5. So even though they're rational numbers, the concept stays the same. I'm going to go ahead. I'm going to separate with my nice, as you can tell, super straight lines. I'm going to come in. I'm going to do the inverse operation. So I'm going to add 4/5 to each side, which keeps everything balanced. These two cancel each other out. So R equals, this is one that might take us a little bit of practice. So I have negative 2 1/4 plus 4/5. So one thing that I know already is that the absolute value of the higher number is negative. So whatever my answer is going to be negative. So off to the side, I go ahead and I put 2 1/4 minus 4/5, common denominator of 20. We're going to multiply each of those by 5. 5 over 20, multiplied by 4. 16 over 20. You probably recognize this from rationals and fractions as a danger. So I'm going to borrow plus 20 20ths, 25 20ths, 9 20ths, and 1. So this would be negative 1 and 9 20ths. So now we still need the proof. So we'll come in, and we'll go ahead and we will take our original equation, r minus 4 fifths. Negative 2 1/4 equals 1 9/20 minus 4 fifths. Negative 2 1/4 equals negative 2 1/4. One thing I noticed that we want to make sure that we do is I noticed that I forgot to put the negative on this. So always be very careful. It's actually a good lesson. Not like I did it on purpose, but keep an eye on when you're talking about what your sign is of your solution. Because if you put in a negative and it's supposed to be a positive or vice versa, it's going to throw it off. So since these are both negatives, negative 1 9/20 minus means plus negative 4 fifths. That's going to give us our negative 2 1/4. Okay, one last thing that we'll talk about, a little higher level skill, but also one that you should be able to do, is I want to use solving one-step equations to solve a real-world problem. So I have a triangle, and I'm trying to find the perimeter, and I want to know this side over here. So I don't know what it is, so I'm going to call that x. What I'm going to do is I'm going to set up, and I'm going to solve and prove an equation to figure it out. So for my perimeter, what I want to do, my equation would be 3 plus 5. Now these are our labels, meters. I don't want to use those as variables. Plus x equals 12. Combine 3 and 5. So we have x plus 8 equals 12. Now I'm ready to solve. Inverse operation. So I'm going to subtract 8 off of each side. Stay balanced. Those cancel. X is isolated. Equals 4. Now I want to go back in and prove it. So I have 3 plus, sorry, color scheme consistent. 3 plus 5 plus x equals 12. 3 plus 5 plus substitute 4 equals 12. 12 equals 12. So what I have shown, and since it's a more of an advanced problem, what I want to do is that means that x equals 4 meters. All right, everybody, good job.